Okay, I'm not going to patronize you by asking you what are the two different types of compression. We're just going to go straight into some harder compression questions. So here's the first one. I don't even know who she is, but someone wants to compress a sound file recording to make sure it's as small as possible for their website. Identify which type of compression she would use and describe how it would compress a file. Okay. So let's rock and roll. Well, you've got your choice of lossy or lossless, but both could be used. So let's talk about both of them. Let's talk about lossy first. So with lossy, a compression algorithm is used. We can then say it removes sounds human ear can't hear. So like background noise. So we use perceptual, music, shaping. What else can it do? Oh, you're running out of space. So what I'm going to do is I'm going to put lossy over here a little bit. We could also reduce the sample rate. So as we know with sounds, you've got your samples, the amount of sample points. The more sample points you have, the higher the quality, the higher the quality, the higher the file size. So we can reduce the amount of samples which we're using and the amount of bits we use within our song as well. So reduce sample rate and resolution. So the less bits we use within a sample, the lower the quality. Okay, data cannot be reverted. That means put back to normal again, or back to the original. So we talked about lossy compression algorithm, remove sounds human ear can't hear, like background noise, using perceptual music shaping. You can reduce the sample rate, the amount of sample points being used, which lowers the quality but it makes the file size smaller, and data cannot be reverted. Or you can choose lossless, where, guess what, a compression algorithm is used. But how this works, it looks for repeated patterns. These repeated patterns, so it's like similar sounds, are turned into numbers. So the sound waves are turned into numbers, are indexed. I'm going to put in brackets turned into numbers. Sounds sent and reverted. Thank you, Bento. Sound sent and are reverted back to the original using the index. So you could use something like Run-Length Encoding, which we'll talk about on a different question. So the sound file will be sent like this: 1, 2, 2, 3, 3. It will have in a table 1 being this sound wave, 2 being this sound wave, 3 being this sound wave, and it's able then to take these numbers and replace them with the sound waves coming back, well, reverting back to the original once it's been sent. So someone gets it like this, which is a tiny file size. When they uncompress it or decompress it, uncompress, we'll use that word. When they uncompress the file, it reverts it back to the original, so it'll be back to this again. I'm hoping you've given, so before we move any further, you can mention either or, lossy or lossless, as long as you explain it well. Give 2 benefits of compressing a file. Well, we've got a couple. Quicker to upload to website. It is talking about a website in a question. So this is me. I'm going to put my videos onto my website. If I don't compress it, this is my website over here. I have to send all my videos one at a time, and it'll take like hours. If I compress it to make the file size smaller, it should take about 10 minutes. So it's quicker for me to put it onto the web server. That means that you guys can go and watch videos. It's also quicker for users to download. Takes up less storage on my server. So my website server has about 20 gigs. Once I use those 20 gigabytes up, I've got to pay for more storage. So I want to make sure that my files are as small as possible. And one more, website won't slow down due to size. There you go, there's some benefits. Okay, so this is looking at run-length encoding. Text file. So we know that text files are like anything with words in them. That's really bad, like a letter, like a story, like what you do in Microsoft Word. So it could be like, Dear Joe, I ate the cat. Okay, whatever. I ate the cat and it then sat on the mat. So run-length encoding is basically a way for us to store patterns, so that we're not having to send all of this. It makes it smaller for us to send, and then someone else, their computer, can put it back to normal again. Run-length encoding, oh my gosh, run-length encoding won't be actually useful for this example I've just given you. But if I was to do this in my letter, so let's make the letter a little bit bigger. I saw a deer and it went to the pool. Run-length encoding looks for consecutive sequences of characters when it comes to text. So in this first part, there's nothing which is repeated in terms of characters. Each is a different letter. So you can't really compress this using run-length encoding. But the second part of the letter, we've got this. We've also got this. We've got two E's, we've got two O's. So what we can do is in run-length encoding is it'll put into a table 1, 2, E, O. So the letter is going to be sent, Dear Joe, blah, 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 blah. I saw a D2. And it'll do D. So what it'll look like, I'm not going to write this bit out at the top, but I'm going to do I saw a D, E, and then I'm going to do 1 because there's another E after this. R. Dear. And it went to the sorry, 1 again. Now you could say it's pretty pointless, and it is pointless even in this example because you know, we can just keep the O here. It's the same amount of characters. But the point being is that if you were to have text which was to have lots of repeated characters, so let's imagine I'm sending some hexadecimal code. So let's do something like this. D, E, E, E. It could be sent as D, E, and then 2 more. But run-length encoding is normally used on images, which we'll look at in a different question. So let me take you back to this question. It says, describe using an example how a text file is compressed using run-length encoding. So I would do my example first. Instead of storing A, I would do A, and I'll do 4. So it's 4 A's, which are going to be grouped together. I'll then explain how it works. It looks for repeated sequences of characters and counts the amount of consecutives. So it basically counts 1, 2, 3, 4 and replaces these with the letter and the amount. When received, so when you send it and it's been received by someone else, it reverses the process. So the second question, explain why run-length encoding will sometimes increase the size of a text file. Well, here's the thing. Having this situation where we've got lots of repeated characters in text doesn't normally happen, as I've just shown you. So it could actually increase or make it stay the same. So like when we had pool, and we could do, okay, P, and then we do O2 for 2 O's, it's the same amount. So repeated sequences for text characters, I'm going to put characters here, rarely occurs. When we do have repeats, like pool, the run-length encoding version would be PO2L, which is the same amount of characters yeah. I can't envisage it being more. I can't envisage it increasing the size, but I can keep it the same. So yeah, that would be my answer. I'm hoping that makes perfect sense to you. Next question. Okay, so this question is split into 2 parts. We've got this bit and this bit. Pause the video, give it a go. Okay, so these are different compression methods. We're going to say if it's lossy or lossless when we send it. So the first one is cropping an image. So if I was to do this and I crop the image, this image is now smaller. It's a smaller file size. If I send this, the other person isn't able to take it back to the original. So cropping is lossy. If I reduce the resolution of an image, that would be lossy. That means that I have less pixels being used, less colors being used. The other person's not going to be able to upscale it and make it better. You can't turn a crap image and turn it to like a beautiful HD one. It's not going to happen. Run-length encoding, well, the whole point of run-length encoding is to put it back together again. So that would be lossless, and reducing the color depth of the image, which is basically the colors being used in the image, lossy as well. We're going to use this to answer this question. How would run-length encoding compress this image? So I'm actually going to describe it and do it as a sample. I'm going to do this side, example. I'm going to do R2, P2, actually P3, and G1. So you notice how G1 is made it slightly bigger because we're having to add the 1 here, but we have compressed it slightly, I believe, 1, 2, 3, 4, 5, 6 characters. 1, 2, 3, 4, 5. Okay, it's the same. Great. Okay. We then got B1, R2, P1, G2. So same with that. I think we've made it worse. 1, 2, 3, 4, 5, 6, 7. Yep. Anyway, that is what it's doing. And that's my example. So how does it work? It looks for consecutive. So remember that word from the last question. Consecutive pixels, in this time instead of letters, instead of characters, pixels of same color, spelt with a U because you're not American. Stores color and number of times. It uses a lossless compression algorithm. And finally, other computer can restore using the color and character. In fact, I would say that if I was doing this, I wouldn't actually do 1, I'll just do G, and I'll just do B instead of B1, instead of P1 I'll do P. So I don't need to put a 1, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, that's better. So yeah, instead of me doing B1, you can just do B. So it will shorten it. Okay, so that is lossless compression using run-length encoding. Okay, so pause the video, give this question a go. Right, so we see that we're using, again, run-length encoding. We've got another image. How would it work? So we're going to be using lossless compression. Using a compression algorithm, what it will do is it'll look for consecutive color pixels and group based on number. Receiving computer can restore original, i.e. I'm going to do B for black. So we've got 1, 2, 3, 4, 5. So it's going to be B5, and then we're going to have W, B, W, B, W. So the rest of these, there's no real pattern. But we have compressed the top row to be B5. Dot, 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 dot to show that. That's how it'll be done. Easy. Pause the video, give this question a go. Okay, this is a trick question where, when I say it's a trick question, I take it all back. I'm expecting that you guys would have spoken about run-length encoding. That is wrong. What we have, I said to you that run-length encoding is not good for text. This question does not mention anything about run-length encoding. It just mentions lossless. For lossless, there are 2 different types we need to know about in terms of compression algorithms. We need to know about run-length encoding. I don't know why I just did an N. So RLE for run-length encoding. And we also need to know about Huffmans Encoding. So this is what we're going to be talking about now, Huffmans Encoding. This is what we use for text. So I'm going to say a CA is used, as always. I'm going to put in brackets Huffmans. Repeated words are put into an index table and replaced by a value So let's see. This is repeated. So I'm going to do my table. This is an index table. I'm going to do instance 1, red. Is green repeated? Oh. Green is our second instance. 2, green. We then have purple. So we've got blue. Is blue repeated? Yes, it is. So that's 3, blue. 4, purple. I completely mess up the order, but it doesn't really matter. Yellow is also repeated. Grey isn't, nor is black. So, in my example, I'm going to do this. This is what's going to be sent to the other person. 1, 2, 5, 2, 4. Blue is 3. Red is 1. Purple is 4. Blue is 3. Yellow is 5. Grey is grey. Black is black. Pink is pink. Red is 1. So that's what's going to be sent to the other person. It's way shorter than this in terms of characters. Receiving computer will restore or revert or decompress or put back to original using the index table. There you go. So let's see where you get the marks. You get a mark for saying compression algorithm repeated words. I should put are identified. Well, actually, no, I can just do repeated words, but I'm going to put are identified. Index table. Replaced by a value. I'm going to put index value because it's like the index value 1. I gave an example. Receiving computer will revert it back to the original. 1, 2, 3, 4, 5, 6. So I've got 6 out of 5. Kind of. Pause the video, give this question a go. Okay, so it doesn't really tell us what type of lossless is going to be used. So, as always, a CA is used. No data is lost. Can be restored. I might just then do if Run-Length Encoding. I'll give a little brief description. If Huffmans, look at my writing. I'll give a little description. So if Run-Length Encoding, it will look for repeated. What's the word I'm looking for? Being received, consecutive values are indexed, i.e. A would become A4. If Huffmans, it'll look for repeated words which will be put into index table replaced by index value. Okay, so we now got different files. See if you can actually tell me, pause the video, each one of these, what are they used for? Okay, so JPEG is image, and this is lossy. A JPEG is a compressed image file format. It can still look amazing, but it's still being compressed. MP3s, which we use, are lossy. The original, if I sing a song right now, I'll do it in WAV. The sound quality would be amazing. Then, if I want to sell it and put it onto like Spotify, I'll put it as an MP3. I'll compress it using lossy. MP4, the same. It'll be lossy. That's what we watch videos. Netflix streams in MP4. It won't do the original quality like what you'll get in a movie theatre because it'll be far too big to send. Zip is lossless. What a zip is I can put lots of things, lots of files, let's say an image of a donkey, my resume or CV depending on where you come from, and I can do a letter. And instead of me sending these to your email one by one, I can group them all together as one zip file, which basically compresses it. So I'll make these files smaller. So it'll look like that big now. You then get the zip file. You will then be able to turn it from this one file back into the original image, resume, and letter. Let me give you an example. This is a file, this is a file, this is a file. I want to send this to you. So I'm going to right click. I'm then going to do send to zip. So these three files are now inside here. I've just made this. I send you this file called hi. You then on your computer uncompress it. And there they are, the three files. That's a zip.